Show by the principle of mathematical induction that for all n belonging to the set of natural numbers, 3 raised to the power of 2n plus 7 is divisible by 8. Okay, let us begin. Now here, the question is not asking us to prove that 3 raised to the power of 2n plus 7 is divisible by 8. It's only asking us to show that it is true, that it's a true statement for any natural numbers. So for that, what we'll do, we're going to consider Pn as a statement. So we're going to represent the statement as Pn. So let P of n be the statement. So this statement is given by the P of B, the statement given by, so here we have P of n such that, so we are considering 3 raised to the power of 2 times n plus 7 is divisible by 8. Right. So we are saying that this is a mathematical statement, and we need to check the validity of this statement, if this is a true statement or not. Now, we'll consider the first n a natural number 1. So for n equals to 1, our statement is now going to become P of 1 such that we have 3 raised to the power of 2 multiplied to 1 added to 7. So that's going to give us, so 3 squared, so that's 9. We have 9 added to 7. So that's going to be equals to 16. Is 16 divisible by 8? 16 is indeed divisible by 8 because that's a fact. 16 is divisible by 8. So here, what we have done here is we have shown that the statement P of n is true. This is a true statement for n equals to 1. Okay, fine. So we have showed that the statement Pn of n is true for n equals to 1, but we'll also have to show that it's equally true for other natural numbers. So what we will do here, we're going to suppose that let P of m. We're saying that P of m is a true statement. This is a true statement. So what is m here? So m is some natural number, where m is some natural number. That means m belongs to the set of natural number, which means that in essence we are saying that P of m such that 3 raised to the power of 2 times m plus 7, we're saying that this is also divisible by 8. This is divisible by 8. Okay, we're making an assumption here, and we're going to name this as statement number 2. If this statement is true, then using this statement, we have to prove, we have to verify that if we consider the next consecutive natural number to that of m, so that is m plus 1, we have to prove that P of m plus 1 is also true. This is our goal, to show that P of m plus 1 is true. That is, in essence, we need to show that P of m plus 1 such that we have 3 raised to the power of 2 multiplied to m plus 1 plus 7. This expression must be divisible by 8 as well. If we can show that this is divisible by 8, then we can conclude that our expression is going to be divisible by 8 for any natural number that we choose. Fine, let's call it number 3. We'll try to verify number 3. To do that, what we'll do, we will use the statement number 2. Now in statement number 2, we assume that P of m is true. That means 3 raised to the power of 2m plus 7 is divisible by 8, which means that we can express 3 raised to the power of 2m plus 7 as 8 times lambda. We can say it's a multiple of 8 since it is divisible by 8, where lambda belongs to the set of natural numbers. Fine, we'll be using this. So now what we'll do, we will take the expression 3 raised to the power of 2 times m plus 1 plus 7, and we're going to simplify it. This gives us 3 raised to the power of 2m added to 2 plus 7. Using the law of exponents, we get 3 raised to the power of 2m multiplied to 3 squared added to 7. Right. So 3 squared, that becomes equals to 9. So we have 9 multiplied to 3 raised to the power of 2m. However, we can use this equation. 3 raised to the power of 2m can be replaced with 8 lambda minus 7. added to 7. So that's going to be equals to, so 9 times 8, well, let's keep it as 9 times 8 lambda, minus 9 times 7, that's 63, added to 7. So we have 9 times 8 lambda, that's minus 56. Now, if we take 8 as the common factor from each of the two terms, we have 8 times 9 lambda minus 7. Essentially, what we have shown here is that this expression can be expressed as a multiple of 8, meaning we have shown here that 3 raised to the power of 2 multiplied to m plus 1 plus 7, this is divisible by, multiple of 8 means it's divisible by 8. If this is divisible by 8, so we have confirmed here that the statement P of m plus 1, this is a true statement. Now, if this is a true statement, we can now generalize everything and say that the original statement P of n is true. This is true for all natural numbers, for all numbers n belonging to the set of natural number. That means for all natural number P of n, where P of n is given by the statement 3 raised to the power of 2n plus 7 is divisible by 8. So this is going to be a true statement. We have successfully used the principle of mathematical induction here.